vertical circular motion. Now until now we have studied bodies moving in a horizontal circle, horizontal plane lo manam chadukunnam. Now we are studying when same bodies when they are moving in horizontal circle. So what is the difference between, vertical circle. So what is the difference between horizontal motion and vertical motion? In a horizontal motion, there is no concept of weight of the body. Weight is not responsible for providing centripetal force. What is the reason? Because when bodies, when they move in this kind of circle, that is in horizontal circle, they are moving like this. Centripetal force is acting towards the center, but weight of the body mg is acting in which direction? Weight of the body mg is acting in downwards direction. So mg, weight of the body, doesn't play any role in providing the centripetal force. Are you able to understand? But here in the case of vertical circle, when bodies are moving in vertical circle, definitely weight of the body plays an important role here. Are you able to understand? Because in a vertical circle, weight mg is acting in this direction. Weight of the bob mg is acting in downwards direction, and tension is acting in upwards direction. So mg and weight, they are acting in opposite directions. Now for a body to move in circular path, when bob is present here, clear number, tension should be greater or mg should be greater? Definitely tension should be greater, no? So then only there will be some force which is acting towards the center of the circle. Clear number? So therefore I will write tension must be greater than mg. Okay. So here if velocity of the bob is v0 and it is rotating with an angular velocity of omega, then how can I write an equation for centripetal force? How can I write an equation for centripetal force, so I can write mg minus t, t minus mg. Because t should be greater than mg, then only there will be some net force acting towards the center. At t minus mg, this provides the centripetal force. That's all. T minus mg centripetal force in produces. And centripetal force will be in which direction? Towards the center of the circle. Okay. So T minus mg is centripetal force, and what is the equation for centripetal force? mv0 square divided by r, if radius of this circle is r. L also you can take, or you can write mr into omega square. Clear number? This is how I can write the equation. Okay. So here, if you take in horizontal circle, there is no relation of weight relating to centripetal force. But here weight is very much related to the concept of centripetal force. So that is why the study of horizontal motion is completely different. Study of vertical motion is completely different. Are you able to understand, ma? So now let us see, for example, if body has reached up to here. Body has reached up to here. So here let us call the tension is T dash. Okay, ma? And here let us call tension is T. Okay, ma? Now bob is making how much angle? Let us consider it is making an angle of theta with respect to vertical line. Are you able to understand, ma? So now here can you say how can I write equation for centripetal force? What about the weight of the bob? Weight is acting in which direction? Weight is acting in downwards direction, no, ma? Weight capital mg is acting in downwards direction. So this capital mg we will split into two components. Clear? So if this angle is theta, definitely this angle also will be theta. So this is mg sin theta and this force is mg cos theta. Are you able to understand? Clear? No? So therefore, how can you write centripetal force? So here velocity, let it be v. Here velocity is v0, no, ma? By the time it moved up to here, what happens to its velocity? Velocity definitely reduces because it is moving up the plane, no? Velocity definitely reduces. Now how can I write a relation between t and mg cos theta? So definitely I can say that t must be greater than mg cos theta, no, ma? T must be greater than mg cos theta. Otherwise there will not be any force acting towards the center of the circle. Clear? So therefore I will write t minus mg cos theta. This provides the centripetal force. And what is the formula for centripetal force? M, here velocity is v, no? So mv square divided by r. That is the equation. Okay, ma? So therefore let us call this is my first equation. Okay. Now if I want to write a relation between initial velocity and final velocity, how can I write it? So first of all, now I have derived a relation for tension, no, ma? Tension. So T minus mg cos theta is mv square divided by r. Okay. Now if I want to write a relation between initial velocity and final velocity, definitely v is less than v0. v0 will be greater than v. Now how can I write a relation between v and v0? Can you say? That is relation between initial velocity and final velocity. V and v0. How can I write it? Can you say? V minus v0? ఏమవుతుంది v minus v0? How can I write a relation between initial velocity and final velocity? That is the question. Anybody? Already we studied in, I think somewhere in Newton's laws we have studied, no? When body covers an angle of theta, then how much angle pendulum will cover, how much vertical height pendulum will cover? L into 1 minus cos theta. Already we have studied, no? Are you able to understand? So therefore, so we will see once again. See. So here the original length of the string is L. And here what is the velocity of the body? Here velocity of the body, let it be V naught. Or you can write U also, initial velocity. Are you able to understand? So after some time, body has reached up to here. Are you able to understand? No? So how much angle it has covered? It has covered an angle of theta. And here let velocity be V. Okay. So length of the string is L. So this is also L, no? So this L, I can split into two components. No? So this is up to here, it is L cos theta. And this one is L sin theta. And this height, if I call it as H, then how can I calculate H value? H value is equals to total L minus L cos theta. This is how I can calculate now. Clear number? So therefore, how can I calculate H value? H value is equals to L into 1 minus cos theta. So this is the vertical height reached by the ball. Okay. So therefore, how can I calculate relation between final velocity and initial velocity? Ma? Completed ma up to here? Huh? Okay. So therefore, I can calculate by two methods. No? Either I can use law of conservation of mechanical energy. Body is moving only because of gravitational force. No? Tension is there, but tension cannot do any work here. Why tension cannot do any work? Tension is always acting in this direction, no? But displacement is in this direction. Angle between tension and displacement? 90. Cos 90? 0. Work done formula? Fs cos theta. Cos 90 is 0, no? So tension cannot do any work. Body is moving only because of what? Gravitational force. The only force which is doing work here is gravitational force. Okay. So if only conservative forces are acting, definitely I can use law of conservation of mechanical energy, no? So K1 plus U1 is equals to K2 plus U2. This relation I can use. No? What is this relation? Law of conservation of mechanical energy. This relation definitely I can use. What is the initial kinetic energy of the body? Initial kinetic energy is half m initial velocity, let us call it as u, half m u square. Clear? At this point, what is the velocity u only? No? So half m u square. Initial potential energy, that depends on reference. No? So let us take this reference to be zero potential energy reference. Okay, ma? Ground point, at the bottommost point I am taking to be zero potential energy reference. Clear? No? So therefore, initial potential energy 0. Final kinetic energy half m v square. Final kinetic energy. Final potential energy mgh. Okay, ma? And what is the height reached by the pendulum? L into 1 minus cos theta. So therefore I will write half m u square is equals to half m v square plus mg L into 1 minus cos theta. Clear number? So mass and mass get cancelled. So therefore what is the final velocity? Ma? So v square is equals to u square minus 2gl into 1 minus cos theta. Clear now? So therefore v is equals to square root of u square minus 2gl into 1 minus cos theta. Clear now? So this is the equation for final velocity of the particle in terms of initial velocity. Okay. So this final velocity I have calculated by using which method? Law of conservation of mechanical energy. Or any other simple method? Ma? If I don't want to do in this method, can you suggest any other method? Already we discussed. If I don't want to do in this method, is there any other further simple method? This is very simple. Further simple method. Kinematics equation we have, no? Kinematics equations definitely you can use, because here tension cannot do any work. Tension cannot do any work. Work is done only by gravitational force. Definitely you can use the equations of kinematics. What is the equation I can use? V square minus u square is equals to 2as. This equation I can use. Clear, no? So final velocity I don't know. Initial velocity is u square. So 2 into body is moving upwards from us, so minus g. And what is the height reached by the body? L into 1 minus cos theta. Clear, no? So therefore v is equals to square root of u square minus 2gl into 1 minus cos theta. So very easily I got this answer, no? Understood, no? Only one step. V square minus u square is equals to 2as. That's it. body is moving upwards, no, so you will take a g minus g you take here. Because speed reduces, no, so you take g value to be minus. See, in circular motion, when body is coming downwards, you take g value positive. When body is moving upwards, you take g value negative. So here we are using a different kind of sign conventions. But in kinematics, we use another type of sign convention. So g is always negative. Like that we have used. You can use here also, but we should be careful. Clear? Understood, Nama? So therefore, velocity I have calculated and equation for tension also I have calculated. So this is one equation for tension. Are you able to understand? And this is the equation for final velocity. And final velocity we got in terms of what? In terms of angle theta and initial velocity. Understood? No? Okay. Now what I will do is, have you drawn this diagram? Okay. Now see. Now I will try to write one more equation for tension. This is one general equation. T minus mg cos theta is mv square by r. This is one general equation. Now I will try to calculate this tension. I will try to derive equation for tension in terms of initial velocity and angle theta. Because final velocity we have calculated in terms of initial velocity and angle theta, norma. Tension also I will try to calculate like that only. Clear? How I can do? Here I have velocity, norma, and here I have equation of velocity, no. So just substitute this velocity here and see what is the equation of tension you will get. Second equation of tension. Okay? So write down. Okay? So another equation of tension. Another equation of tension. So how can I calculate? Just take this equation. So T minus mg cos theta is equal to m by r multiplied by v square. V square instead of v square I can write u square minus 2gl into 1 minus cos theta. Clear now? Okay. Now you are supposed to simplify this one. Okay. So simplify that equation and I am writing the final equation. T is equals to mu square by l minus 2mg plus 3mg cos theta. Clear now? So this is the final equation which you should get if you solve this total equation. Derivation part I am not doing, you try to do the derivation. Understood, Dhamma? So therefore, one equation I got for tension, one equation I got for final velocity, and this is the third equation again in terms of tension. Clear? So just instead of velocity we have substituted this equation. Then I got another equation. Okay? Okay, ma'am? So therefore this is that angle where velocity will become 0. Now let us do that angle where tension becomes 0. Okay, ma'am? Tension becomes 0. So what is the equation for tension? See, again just like the same condition. So initial velocity is u. Then this bob after traveling a particular angle, tension may become how much? Tension also may become 0. So this is the condition where velocity is becoming 0. Now we are writing a condition where tension will become 0. Clear, Nama? And let that angle I will call it as beta. Alpha is the angle where velocity becomes 0 and beta is the angle where tension becomes 0. So I have to equate the tension to be 0, Nama. What is the equation for tension? Mu square by L minus 2mg plus 3mg cos theta. So total should be equal to how much? Total should be equal to 0. Okay. So therefore mass, they will become get cancelled. So therefore if I do this calculation, you will get theta is equals to cos inverse of 2gl minus u square divided by 3gl. Okay, ma? And this calculation you should do. And this angle I will call it as beta. Okay. So what is meant by beta? Beta means what? It is that angle where tension will become 0. And what is this angle? Alpha. Alpha is that angle where velocity will become 0. What is the difference? Here in the denominator I have 2gl. Here in the denominator you will find 3gl. That's it. That is the only difference. Fine? Cases we are discussing, and first case is case number 1, where initial velocity of the pendulum is root 2gl. What is meant by initial velocity? When bob was present at the bottommost position here, then how much initial velocity we are giving? We are giving an initial velocity of root 2gl. Clear? And in these cases also you should remember very carefully. So 3 to 4 cases we will study. So what is the initial velocity with which I am throwing this one? Root 2gl. Clear now? So when initial velocity is root 2gl, then I will find these angles. What is meant by these angles? This is the angle where velocity will become 0. It means I want to calculate that angle where velocity will become 0 if initial velocity is root 2gl. Similarly, then I will calculate beta. What is beta? It is that angle where tension will become 0 again when initial velocity is root 2gl. Clear? Now let us. So first of all I will take alpha value. So alpha value is that value where velocity will become 0. So cos inverse of 2gl minus, and instead of u square I can write 2gl no? U means initial velocity no? Instead of initial velocity I can write 2gl. So 2gl divided by 2gl. Clear? 2gl minus 2gl? 0. 0 by anything? 0. Vivek, Umesh, Venaton ledu meeru. Okay. So cos inverse of 0. So cos inverse of 0? 90 degrees. That's all no? So therefore cos 90 is 0 no? So cos inverse of 0 is 90. So therefore I got alpha value is 90 degrees. So what do you understand by alpha value is 90 degrees no? It means when I throw this pendulum with a velocity of root 2gl, then body after covering an angle of 90 degrees, its velocity is going to become 0. Because it is that angle where velocity will become 0 no? So it means bob will cover how much angle? Bob will cover 90 degrees. So alpha value is 90. And here its velocity is going to become 0. If I throw with how much velocity ma? If I throw with the velocity of root 2gl velocity. Understood no? Clear? Similarly, let us calculate beta value. Beta means what? Where a tension will become 0. So therefore, beta value is equals to cos inverse of 2gl minus u square divided by 3gl. Okay. Now again substitute. So beta is equals to cos inverse of 2gl minus, what is the initial velocity? Root 2gl. Square of root 2gl is 2gl divided by 3gl. Clear number? So beta value is again how much? Again it is equal to 90 degrees. Clear no? So what is meant by beta also 90 degrees? It means that tension is also going to become 0 after covering an angle of 90 degrees. Are you able to understand? No? So not only velocity will become 0, but tension also will become 0 at 90 degrees. If I throw with how much velocity? Root 2gl velocity. Understood now? So this is one case. Okay. So let us study case number 2. Okay, my case number 2 is if initial velocity is root 4gl. Second case. Okay. So if initial velocity is root 4gl. Okay. It means with how much initial velocity I am throwing this one? With an initial velocity of root 4gl. Case number 2. So here also 4gl. Clear number? But whatever it may be, again it will become 0 only, no? Because 2gl minus 2gl. 2gl minus 2gl minus 4gl. So therefore, let us see how much we will get now. So I will get cos inverse of minus 2gl. This is 2gl only, no? Sorry. This is 2gl. So therefore, minus 2gl divided by 2gl. So how much it is? Cos inverse of minus 1. So what is meant by cos inverse of minus 1? 180 degrees. Because cos 180 is minus 1. No? Cos 180 value minus 1. So cos inverse of minus 1, 180 degrees. So therefore I will get alpha value is 180 degrees. Now what do you understand by alpha is 180 degrees? It means body's velocity will become 0 after reaching 180 degrees. Clear now? That means if I can draw the diagram of this one, clear now? Body will travel like this in this circular path, and by the time it reaches here, what will be its final velocity? Final velocity will be 0. So how much angle it will cover? It will cover an angle of 180 degrees. Clear now? Similarly, you calculate a beta value, 2gl minus u square divided by 3gl. Initial velocity is root 4gl number, so 4gl divided by 3gl. So therefore, if I do this calculation, what I will get? I will get beta is equal to cos inverse of minus 2gl divided by 3GL. So GL and GL, if they get cancelled, so beta is equals to cos inverse of minus 2 by 3. Okay, ma? Cos inverse of minus 2 by 3 is approximately 133 degrees. In between, it will be in between 140, 130 and 140. Approximately 133 degrees. Okay. Now, what is meant by 133 degrees, ma? At 133 degrees, tension is going to become 0. But velocity will become 0 at what angle? Velocity will become 0 at 180, but tension is becoming only at 133. Okay. What do you understand? What we understand is after 133 degrees, body cannot move in a circular path. Okay. But definitely it has the ability to travel up to 180 because velocity is becoming 0 only at 180. But tension is not supporting. No? Tension supports it only. So body cannot move in a circular path after 133 degrees. Because for a body to move in a circular path, which force is required? Centripetal force, and here tension is the main force which provides centripetal force. No? If tension is 0, can body move in a circular path? No, it cannot move in a circular path. Tension is becoming 0 at 133. So it will travel in circular path only up to 133. Beyond that, it doesn't move in a circular path. Then how it moves? Let us. Clear now? So therefore, what is the note points here we have to write? Body has ability to reach 180 degrees, but tension is not supporting. Tension is not at all supporting, no ma? Are you able to understand? So therefore, after 133 degrees, body moves in a parabolic path. It moves in which path, ma? It moves in a parabolic path and not a circular path. What is the meaning of that? Let us. Clear? See, ma. So this is the bob. Are you able to understand? And what is meant by 133? Approximately this angle I can call it as 133. Greater than 90, no ma? This angle is 133 degrees. Okay. So here what will become 0? Tension will become 0. Beta, tension will become 0. But velocity, is it 0? Velocity is not 0. Why? Because velocity will become 0 only at 180 degrees only. Understood now? So here tension is 0, so it cannot move in a circular path from here. Up to here it has completed the circular path very carefully. But from here onwards it moves in a tangential path. It moves in a what you call parabolic path. అర్థమవుతుంది కదమ్మా? 133 వరకు సర్కులర్ పాత్లో వెళ్తుంది. 133 దగ్గర టెన్షన్ 0 అయిపోయింది, కానీ వెలాసిటీ మాత్రం 0 కాదు. వెలాసిటీ 0 ఎక్కడవుతుంది? సో అక్కడ నుంచి అదేం చేస్తుంది? ఇట్ మూవ్స్ ఇన్ ఏ పారాబోలిక్ పాత్, యాజ్ ఇఫ్ సంబడీ హ్యాస్ థ్రోన్ ఎ స్టోన్. If you throw a stone at an angle, it travels a parabolic path, according to equations of kinematics, it will travel. Are you able to understand? So that is what happens if I give how much velocity, ma? If I give a velocity of root 4GL velocity. Okay, ma? So previously we have studied two cases, ma? First one was body thrown with an initial velocity of root 2GL, and what was the second case? Body was thrown with an initial velocity of root 4GL. So these two we have studied, no? Okay. So do you remember what happens if I throw the body from the bottom of the circle with the velocity of root 2GL? Emautundi? If I throw with the root 2GL, then what will happen? Velocity will become 0 at 90 degrees. Tension also will become 0 at 90 degrees. This is what we have studied, no? Are you able to understand, no? Similarly, if I throw the body with an initial velocity of root 4GL, so velocity is going to become at 180 degrees. It will become 0 at 180 degrees. What about tension? Tension will become 0 at what angle? At an angle of 133 degrees. This is what we have studied, no? So therefore, body will move in a circular path up to 133 degrees, and from there onwards, it moves like a projectile. That's what we have studied in first two cases. Now we are studying the final case, which is called as if I throw the body with an initial velocity of root 5GL. Clear? Now, if initial velocity is root 5gl, then here also we will calculate alpha values and beta values. What is alpha value? Alpha value is that value, that angle at which velocity will become 0. No? So therefore cos inverse of 2gl minus u square divided by 2gl. This is the equation number. So substitute here. So therefore it is cos inverse of 2gl minus, what is the initial velocity? Root 5gl. Root 5gl whole square is 5gl divided by 2gl. Clear now? So therefore it is equals to cos inverse of minus 3gl divided by 2gl. That's all number. So gl and gl, if they get cancelled, then it is called cos inverse of minus 3 by 2. Okay. So this is the alpha value which I got. Okay. So what is the alpha value I got? Alpha value is cos inverse of minus 3 by 2. Are you able to understand, ma? So it means it is that angle where velocity will become 0. Okay. And cos inverse of minus 3 by 2 is how much? Cos inverse of minus 3 by 2, it is not possible. Asala the possible kaadu. Enduku? The maximum values of sin theta and cos theta is only plus 1 and minus 1. Sin 0? Sin 0. Chappanda tvaraga. Sin 0. 0. Sin 90? Sin 90? 1. Sin 180? 0. Sin 270? Minus 1. Sin 360? 0. So sin values, they are varying only from plus 1 to minus 1. Similarly, cos values also, they only vary from plus 1 to minus 1. Beyond that, sin theta values and cos theta values cannot reach. Okay. But if you see here, cos inverse of minus 3 by 2, it is greater than 1, no, magnitude wise, it is greater than 1. 3 by 2 means 1.5, no? So is it possible? So this angle is not at all possible. Cos inverse of minus 3 by 2, there is no such angle. Are you able to understand? So therefore what I say, therefore, this angle is not possible. This angle is not possible. It is not at all possible. Angle is not possible means what? Velocity cannot be 0. That is the meaning of this one. So this is that angle where velocity will become 0. And velocity is becoming 0 at what angle? This angle. Is this angle possible? Not possible. It means velocity will never become 0. That is the meaning of it. So even body reaches to the topmost position, there also velocity is not going to become 0. Is it clear? So therefore what I say, velocity never becomes 0. Velocity is never going to become 0. If I give how much velocity, ma? If I give a velocity of root 5gl at the bottom of the vertical circle. Is it clear? Okay. Similarly, let us calculate beta value. What is beta value? Beta value ante? It is that angle where tension becomes 0. That's what we have studied now. And what is the formula? Cos inverse of 2gl minus u square divided by 3gl. That's all, no? So substitute here. So therefore beta is equals to cos inverse of 2gl minus initial velocity 5gl divided by 3gl. Clear, no? So therefore beta is equals to cos inverse of minus 3gl divided by 3gl. So therefore it is cos inverse of minus 1. So cos inverse of minus 1, 180 degrees, because cos 180 is minus 1 number. So cos inverse of minus 1 will become 180 degrees. So therefore beta value is how much? Beta value is 180 degrees. So what do you understand by beta is 180? So tension becomes 0 after covering an angle of 180 degrees. And 180 means where? 180 means the topmost position, no? This position. It means the body will travel up to here in a circular path because tension is present, no? Tension is becoming 0 where? Tension is becoming 0 only at 180 degrees. Up to that tension is present, no? So therefore definitely it travels in a circular path up to 180 degrees. And velocity is never 0. Velocity is never becoming 0. And tension is becoming 0 only at 180 degrees. So definitely body will travel in a circular path up to 180 degrees. Clear, no? And after reaching 180 degrees, is velocity 0? After reaching 180 degrees, velocity is it becoming 0, ma? No. Okay. So even after the body reaches this position, velocity is not 0. Velocity is not 0 means what? It continues to travel in this direction. Once it continues to travel in this direction, tension again will develop. Mulli tension ఏమవుతుంది? Mulli tension develop avadamu start అవుతుంది. Are you able to understand? So therefore body will continue to travel in a circular path. Are you able to understand? So therefore this is the minimum velocity which I have to give at the bottom of the vertical circle so that body can move in a circular path. Okay, ma? బాడీ సర్క్యులర్ పాత్లో వెళ్ళాలి అంటే మినిమం ఎంత వెలాసిటీ ఇవ్వాలి మనము? ద మినిమం వెలాసిటీ షుడ్ బి గివెన్ ఈస్ √5g. Are you able to understand? That's all. So write down. So after reaching 180 degrees, tension is 0, but velocity is not 0. Therefore, Bob continues to move. Bob continues to move, and again tension develops. Okay, ma? So therefore, U minimum is equals to √5gl for a body to complete a circular path. To complete a circular path. Are you able to understand, ma? So what is the minimum velocity with which we have to travel? The minimum velocity with which we have to travel is, with which we have to throw is √5gl, so that a body can complete a circular path. Okay, ma? If I am throwing with a velocity of √2gl, it was not able to complete. With a velocity of √4gl, then also it was not able to complete. It was able to complete only if I throw with a velocity of √5gl. So this is the minimum velocity required. Minimum velocity required for a bob to complete a circular path is √5gl. Clear now? Now if I throw with this much of velocity at the bottom of the circle, I want to calculate what will be the velocity of the body at this position. Okay, ma? That is when it covered 90 degrees. Here if velocity is v1, I want to calculate v1 value. Similarly, by the time this body reaches here, topmost position, here let its velocity is v2, and now total how much angle it is covering, ma? 180 degrees. So this v2 value also I want to calculate. Okay. Anybody, can you say how can I calculate, ma? I am throwing with a velocity of √5gl. Now after body covers 90 degrees, what is its velocity? Similarly, after covering 180 degrees, what will be its velocity? Ela cheyochu? How can I do? What is that equation for? We have already derived one equation for final velocity. Now what is that equation? V is equals to square root of u square minus 2gl into 1 minus cos theta. This equation already we have derived. No? What is u? U is nothing but initial velocity. Theta is nothing but angle covered by the body. So can't you calculate final velocity? Come on, calculate. So v is equals to square root of, what is the initial velocity? Initial velocity is √5gl. So root of square of √5gl is 5gl minus 2gl into 1 minus cos 90. So this is the velocity of the body after covering 90 degrees, number v1. Okay, cos 90, 0. So square root of 5gl minus 2gl. So therefore it is √3gl. Okay, so this will be the velocity at point number 1. Understood, number? So therefore at the first point velocity will be √3gl. Okay. Similarly, let us calculate what is the velocity after covering an angle of 180 degrees. So velocity at point 2, v2. Okay. So v2 is equals to square root of u square minus 2gl into 1 minus cos theta. Again same equation. So v2 is equals to square root of 5gl minus 2gl into 1 minus cos 180. Cos 180 value minus 1. Minus 1, no? So minus of minus will become plus, no? So 1 plus 1 is 2. 2 into 2 is 4. So therefore how much I will get? V2 is equals to square root of 5gl minus 4gl. So V2 is equals to √gl. Okay, ma? So these are very, very important results. Clear, no? Are you able to understand? Now let us see what is the importance of them. See one. So it means if I want to release this body or if I want to throw this body from the bottommost position, then what is the velocity with which I have to throw? √5gl. Okay, ma? Same body, if I want to throw from here, here I am holding this body and here I want to give it some velocity. Then what is the minimum velocity so that it can complete a circular path? Minimum velocity is √3gl. Okay. Similarly, at this point, I am holding this body at the topmost point and here I want to give some velocity so that again it completes a circular path. Then at the topmost point, what is the minimum velocity? √gl. So that is the importance of these velocities. If you want to throw from the bottom, this is the minimum velocity. If you want to throw at an angle of 90 degrees or from the midpoint of the circular path, then the minimum velocity required is root 3 GL. And from here if I want to throw, again the minimum velocity is root GL. So less than this velocity if you throw, body is not going to complete a circular path. You should throw either at this velocity or a velocity greater than this velocity. Then body can complete a circular path. అర్థమవుతుంది కదమ్మా. సో ఈ పాయింట్లో ఇది మినిమం వెలాసిటీ, ఈ పాయింట్ దగ్గర ఇది మినిమం వెలాసిటీ, ఈ పాయింట్ దగ్గర అది మినిమం వెలాసిటీ. ఓకే, సో దేర్ ఫార్ వాట్ ఈస్ దిస్ వన్? దిస్ ఈస్ ద V minimum velocity at first point. Clear nama? And what is this one? This is the minimum velocity at which point? At second point. Point number 1, point number 2. So that is the importance of these velocities. Okay, that's it. We have calculated at different positions. Now I want to calculate tension at different positions if I am throwing the body with a minimum velocity of root 5 GL. And what is the equation for tension? Tension is equals to mu square by L minus 2 mg plus 3 mg cos theta. Clear nama? So this is the equation for tension. No? Okay. So here let us call tension to be TL. The lowest position I am calling tension to be TL. At the middle position, what shall I call this one? Let here tension be TF, middle position. Similarly here at the topmost position, let tension be TH, tension at the highest position. Now initial velocity already I have, no, and angles also I know, no. Just substitute and see what is the tension you will get at 3 different positions. Okay, come on, calculate it. So tension at lowest point, m by L into initial velocity is root 5 GL. Root 5 GL whole square is 5 GL minus 2 mg plus 3 mg into cos 0, because at the initial position angle is 0 only, no, cos 0. Okay, so therefore how much? L and L get cancelled, so 5 mg minus 2 mg plus 3 mg. Clear, no? So therefore TL is equals to 6 mg, na? 6 mg. So this is the tension at the lowest point. Clear, no? Lowest point is 6 mg. What is meant by 6 mg, ma? Mg means weight of this bob, no? Mass of this bob is how much? M. So its weight is mg. So at the lowest point, what will be the tension? It will be equal to 6 times the weight of this body. Clear, no? This is another important result. So it is 6 times the weight of bob. So where is the tension here? At the lowest position. Clear, no? Then you calculate tension at the middle position. Okay. So tension at middle position is equals to m by L into root 5 GL minus 2 mg plus 3 mg cos 90. Cos 90 value 0. Clear, no? So root 5 mg whole square. So tension at middle point is equals to how much, ma? So 5 mg minus 2 mg plus 0. So total how much it is? 3 mg. Okay, ma? So tension at the middle point, that is at an angle of 90 degrees, is 3 times the weight of the body. Clear, no? 3 mg. Fine. Then tension at highest point already we have calculated. No, tension at highest point is 0. Okay. If I throw a body with an initial velocity of root 5 GL, tension will become 0 at 180 degrees only. No, already we have calculated beta value. No, beta value is how much? 180 degrees. With how much velocity? With an initial velocity of root 5 GL. So tension at highest point is always 0. Already we have calculated. No, or if you want to prove, always you can prove. Tension at highest point is m by L into root 5 GL whole square minus 2 mg plus 3 mg cos 180. At highest point angle is 180, no? Okay. So tension at highest point is how much? 5 mg minus 2 mg minus 3 mg. So total it is equal to 0. So tension at highest point is 0. Clear, no? So these are another very important results which we are supposed to remember. Okay, ma? So one more, generally he will ask question on this parameter also. What is that? Is TL minus TH. Difference between tension at lowest point and tension at highest point. With how much velocity? With an initial velocity of root 5 GL. This you should not forget. Clear, no? Then how much? Tension at lowest point is how much? 6 mg. Tension at highest point is 0. So therefore this is equal to how much? 6 times the weight of the ball. 6 times the weight of the ball. Okay, that's it. So this is about velocities at different points and tensions at different points. అర్థమవుతున్నాయి కదా? Very very simple calculation. Vertical circular motion appears like equations are very tough, but actually it is very easy. Okay, once you derive the equations carefully and you can, if you remember the results, then it will become very very easy. Okay. So in the first case we have studied about motion of a bob in a circular path with the help of a string. ఒక తాడును ఒక రాయి కట్టేసి వర్టికల్ సర్కిల్లో రొటేట్ చేసిన కండిషన్ మనము చదువుతాం. నౌ వాట్ వీఆర్ స్టడీయింగ్ దిస్ ఈజ్ ఏ ఇన్నర్ సర్క్యులర్ సర్ఫేస్, or you can call it as a concave surface. In this concave surface a mass of m, it is traveling with an initial velocity of u, and the surface is frictionless surface. Are you able to understand? Now Sima, when this body starts moving in this circular path, okay, for example let us consider initially it was here, this was the starting of the circle, it was traveling with an initial velocity of u, and this is the center of the circle. Okay, so radius of the circle, let it be L, or anything you can write. Now after some time this body will reach up to here, no? Are you able to understand? After some time, after covering an angle of theta, body will reach up to here, and here definitely velocity will be reduced, and here let velocity be v. Are you able to understand? Now for a body to move in a circular path, what force is required? Centripetal force is always required. Now here also body is moving in a circular path only. Who is providing the centripetal force? Centripetal force ni evaru provide chestunnaru? Normal reaction. Okay, so normal reaction will be in which direction? Normal reaction will be towards the center of the circle. Clear now? Only normal reaction is providing centripetal force. Only normal reaction. No. Is there any other force? Very good. So weight of this body is acting downwards. No? Weight is how much? mg. Mg you split into two components. Clear now? So if this angle is theta, this angle is also theta. Clear? What is the opposite side? mg sin theta. Adjacent side? mg cos theta. So normal reaction and mg cos theta, they are acting exactly in opposite direction. No? Okay. Then which force should be greater than which force? N should be greater, or mg cos theta should be greater? N should be greater. Then only there will be some force acting towards the center of the circle. Clear Nama? So definitely I can say N must be greater than mg cos theta. Clear? So how can I calculate centripetal force? N minus mg cos theta, it provides the centripetal force, net force acting towards the center. And centripetal force formula, mv square divided by r. Here radius I have taken L normal, so mv square divided by L. Okay, so this is the equation which provides the centripetal force. Same equation we have studied in motion of a bob also, no? There instead of normal reaction, there we have used a tension. There tension was providing the centripetal force. Here normal reaction is providing the centripetal force. That's it. That is the only difference. Are you able to understand, ma? In the case of a bob moving with the help of a thread, clear? By the time it reached here, tension was acting in this direction, weight mg was acting in this direction. So this weight mg I have split into two components. Clear number? This is theta and this is also theta. This is mg sin theta and this was mg cos theta. Clear now? So T minus mg cos theta was providing the centripetal force. But here N minus mg cos theta is providing the centripetal force. Exactly same conditions. So what is the most important point here I have to write? Note point is that this case is exactly analogous. This case is exactly analogous to what? Analogous to motion of a bob in a vertical circle. Motion of a bob in vertical circle with the help of thread. With the help of thread. Are you able to understand? So what are the cases we have studied in the case of thread? Motion of a bob with a thread. Same cases you can apply here also. Exactly same cases. Okay. What were the cases we have studied? Case number 1. Initial velocity root 2 gl. That was the initial velocity number. So if initial velocity was root 2 gl, alpha value was 90, beta value also 90. Do you remember? What is alpha? Angle at which velocity becomes 0. Beta, angle at which tension becomes 0. Okay. Beta was also 90. And similarly, case number 2 was what, ma? Chapali. Initial velocity was how much? Root 4 gl. Root 4 gl. Alpha value 180. So velocity was becoming 0 at 180 degrees. Clear no? Beta value 133 degrees. Okay, so what is meant by 133 degrees? After reaching 133 degrees, the tension will become 0, and here normal reaction will become 0. Understood, Amma? That means that body after reaching up to this point, okay, ma? So when total angle is equals to 133 degrees, here velocity is not 0, but normal reaction will become 0. In the case of Bob, tension was becoming 0, no? Here normal reaction will become 0. What is meant by normal reaction is 0? Normal reaction is 0 means what? Normal reaction is 0 means body loses contact with this surface. That is the meaning of it. Body ki curved surface ki madhyalo contact undadu. Then only normal reaction will become 0. Okay, ma? So from 133 degrees, it no longer moves in a circular path. Inga the circular path lo move avatamu stop chesi, it travels in a parabolic path like this. Are you able to understand? So that is what happens in the case of case number 2. Exactly same case. In pendulum also we got same condition, no? Here also same condition. Okay. Next, case number 3. So what is case number 3? Initial velocity was how much, ma? Root 5 GL. This was the initial velocity. Okay. So if I throw it an initial velocity of root 5 GL, then what is alpha value? Alpha is not possible. Okay, ma? Alpha is not at all possible. What is meant by alpha is not at all possible? So there is no angle at which velocity will become 0. Already we have studied, no, velocity never becomes 0. So therefore, velocity never becomes 0. Okay. But what was the beta value? Beta value was 180 degrees. No? So it is that angle where tension will become 0. It means at the highest point, velocity is not 0, but normal reaction will become 0. But velocity is not 0, no? Again it continues to move in the circular path. Once it continues to move in the circular path, again normal reaction develops. So body continuously it can move in a circular path. So here also what is the minimum velocity required? Root 5 GL. Minimum velocity required here also is root 5 GL. That's it. Clear now? Same case. Pendulum case and this case exactly they are same. Fine. So let us see what is the next case we are studying. Next case is motion of a uniform rod in a vertical circle. Clear now? So previously we have taken bob connected with a string, no? Stone or any ball or any metallic ball connected with a string. But here we are taking a uniform rod and this is the axis of rotation, and around this axis this rod is rotating. Okay. Now here I want to calculate what is the minimum velocity that I have to give at the bottom of this rod. U minimum is how much, such that it can complete a circular path. Adi oka circular path complete cheyali ante how much minimum velocity I have to give. Okay, same. So for example, if I take case number 1, clear number, u is equals to root 4 GL velocity if I give to this rod at the bottommost point, length of the rod is L. So how much initial velocity I am giving, ma? Root 4 GL velocity. Can it complete a circular path or not? If I give a velocity of root 4 GL, this rod, can it complete a circular path or not? Circular path ni complete cheyagalugutunda ledha? In the case of bob, bob lo complete avutunda? In the case of a bob connected with the string, was it able to complete a circular path? No, it was able to complete only up to 133 degrees. After that, a tension or normal reaction, they were becoming 0. Okay, so it was not able to complete a circular path. If I give a velocity of root 4 GL in the case of a bob or in the case of motion of a body in a convex circle, inner circle, then after reaching 133 degrees, what was happening? After reaching 133 degrees, okay, ma? After reaching this angle of 133 degrees, tension and normal reaction, they were becoming 0. So from here, body was moving in a parabolic path, just like a projectile. Clear? But here this rod, here also tension will become 0 at 133 degrees. But this rod, it cannot move in a circle, in a parabolic path. No? Rod parabolic path lo move avvalugutunda. If it is a particle, it can move in a parabolic path. If it is a particle, it can move like this. But this is a rod, no? Rod cannot move in a parabolic path. So definitely, even if you give a velocity of root 4 GL, definitely this rod will complete a circular path. Okay, ma? But in the case of bob as well as motion of a body in a concave circle, minimum velocity was root 5 GL. But here minimum velocity is how much? Root 4 GL. Are you able to understand? Ikkada root 4 GL is the chalu. Definitely it can complete a circular path. Okay. So let us see what happens at 133 degrees, ma. So at 133 degrees, tension changes direction. Tension changes direction. The direction of tension will be changed and tension will never become zero. Okay, why? See, in this condition, tension was in this direction when Bob was here. For example, if you take the bottommost part of this rod, tension will be in this direction at the initial condition. But at 133 degrees, tension will change direction. This is the direction of tension. Okay, ma'am? So previously it was towards the center, no? Now at 133 degrees it is away from the center. So that is what happens in the case of a rod. Okay. So tension is never becoming zero, no? So just the direction of tension is changing at 133 degrees. And velocity never becomes zero, no, ma? If I give a velocity of root 4 GL, will velocity become zero here? Velocity never becomes zero, no? Velocity will become zero only at 180 degrees. If I give how much velocity? Root 4 GL velocity. Already we have studied, no? So velocity is never becoming zero and rod cannot compress, no? For this rod to move like this, what should be the size of the rod? Size of this rod should compress. Is it possible? No. So therefore, for a rod to move in a circular path, minimum velocity required is root 4 GL. Okay? And at 133 degrees, what is going to happen? The direction of tension is going to change. So right now. So therefore, for a uniform rod to move in a circular path, what is the minimum velocity required, ma? Minimum velocity required is root 4 GL. Okay? So even with a velocity of root 4 GL, it can definitely move in a circular path. That is the condition. Next application. So motion of a body in a frictionless tube. We know tube, no? Tube of a tire. Clear, no? Inner layer of the tube, outer layer of the tube. So in this tube, a body of mass m is moving, and consider this is a frictionless tube, a tube without friction. Okay. Now the question is, what is the minimum velocity I should give to this body so that it can complete a circular path? Is it root 4 GL or is it root 5 GL? Which velocity I should give? Minimum velocity. ఆలోచించండి. Very easily you can say if you have understood the previous concepts clearly. Okay, ma? So here, what is the minimum velocity I have to give so that it can complete a circular path? Shall I give root 5 GL or root 4 GL is enough? Root 4 GL is enough. How can you say? How can you say? How can you say that root 4 GL is enough? Normal reaction zero. పోయిన తర్వాత ఏమవుతుంది? Sima. So here also the minimum velocity required is root 4 GL. Root 5 GL is not required. What is the reason? Reason is, Sima, at if I give a minimum velocity of root 5 GL, then what is alpha value? Alpha value is 180 degrees. No? Alpha means what? Angle where velocity will become zero. Velocity will become zero only after reaching 180 degrees. But what about beta? Beta is 133 degrees. No? So this is the angle where tension will become zero. In this condition, normal reaction will become zero. So therefore, if this is the center of this circle, body after reaching 133 degrees, okay, ma? After reaching an angle of 133 degrees, what happens? Normal reaction will become zero, but velocity is not zero. This is what we have studied now. Okay. So what is meant by normal reaction is zero? It means that it loses contact with the outer surface. It loses contact with the outer surface. But when it loses contact with the outer surface, where it will fall? It will fall on the inner surface. Clear, no? It falls like this. It falls on the inner surface. So once it falls in the inner surface, again normal reaction will develop. No? Clear, no? But velocity, is it zero? Velocity is not zero, so it continues to move. And it reaches to the bottommost position, and by inertia, again it will fall down. Once it falls down, again it gains a velocity of 4 GL. Again it goes to 133 degrees. Again it falls on this body. Are you able to understand? So it continues motion like this. So therefore at 133 degrees, what is happening? Body is losing contact with outer surface and it is falling on the inner surface. But velocity is not zero, no? So it will continue its motion. That is what will happen. Are you able to understand? So write down. So therefore, at 133 degrees, if I give how much velocity? Root 5 GL velocity. At 133 degrees, body loses contact. Root 4 GL. What did I say? 5 GL. Okay. Body loses contact with outer surface of tube. Outer surface of tube and falls on inner surface. Okay, ma? As velocity is not zero at 133 degrees, body continues to move in a circular path. Body continues to move in a circular path. That is the condition. Understood? Now we are studying about motion of a body on top of a circular path. So previously we studied motion of a body inside a curved path, that is concave surface, and this is what kind of surface? This is a convex surface. Motion on top of this convex surface. So frictionless surface, mass of the body is m, initial velocity is u. Okay. Then after some time, what will happen? After some time, let us consider body reaches up to here. Okay. Body reaches up to here, and its final velocity, let it be v. It has covered an angle of theta. Are you able to understand? Now, how can I calculate this final velocity? How can I calculate this final velocity? Very easy. Use the equation. Either you can use law of conservation of mechanical energy, or just you can use the equations of kinematics also. Okay. So v square minus u square is equals to 2as. Clear now? So when it is falling downwards, will its velocity increase or decrease? Velocity increases, no? So you take a g value to be positive. Okay. And what is this height? Height or depth by which this body comes down? When body moves in a circular path and when it covers an angle of theta, then what will be the vertical height? Already we have calculated that one. No? H is equals to L into 1 minus cos theta. Always you can apply this. When body is moving up or when it is moving down also, always you can use this relation. H is equals to L into 1 minus cos theta. So total radius of the circle is L. Clear now? So right now. Final velocity I don't know. Initial velocity is u square. So 2 into g into displacement. Displacement is L into 1 minus cos theta. Clear now? So therefore v is equals to square root of u square plus 2gl into 1 minus cos theta. This is the relation. Okay, ma? Previously also we got equation for velocity, no, ma? But what was that equation? V square u square minus 2gl into 1 minus cos theta. But here velocity will increase, no? So we are getting u square plus 2gl into 1 minus cos theta. Understood? No? So in the previous cases velocity was minus, and here we are getting plus. Okay. And here can you say who is providing the centripetal force? Here who is providing the centripetal force? Can you say? In this condition, who is providing the centripetal force? mg. So normal reaction will be in this direction, no? Weight of the bob, mg will be acting downwards. Clear, no? This mg I can split into two components, no? If this angle is theta, this angle also will be theta. So this is mg sin theta. And what is this one? This is mg cos theta. Now can you say who is providing the centripetal force? mg cos theta? Okay, ma? So therefore here I can say mg cos theta should be greater than normal reaction. Clear, no? Because the force which is acting towards the center, that should be a bigger force. Okay. So therefore I can say mg cos theta minus normal reaction provides the centripetal force. And here if velocity is v, then centripetal force is mv square divided by L. Understood now? And already we have, so this is one equation for centripetal force. Clear now? And v value already we have calculated now. So take this v value and substitute here. Okay. If I take v value and substitute here, then I will get equation for normal reaction. Understood now? So therefore substitute it. So therefore mg cos theta minus n is equals to m by L multiplied by square root of u square plus 2gl into 1 minus cos theta whole square. Clear now? So if you do this total calculation, you will get n value, and n value is minus mu square by L minus 2mg plus 3mg cos theta. Okay ma? So this calculation part I am not doing ma. You leave small gap there and you try to do the calculation. Okay? So this is the equation for normal reaction which you will get if you solve this equation. Understood? So previously also we got almost the same type of equation for tension and normal reaction. What is the difference? Difference is minus. Previously we were getting mu square by L minus 2mg plus 3mg cos theta. But here we are getting minus mu square by L minus 2mg plus 3mg cos theta. Understood now? That's it, very very simple. Okay. So similarly I want to calculate what I want to calculate. Angle at which body loses contact with convex surface. Okay ma? So I want to calculate that angle when body loses contact with the convex surface. See ma, if this body starts sliding downwards, permanently it cannot move in a circular path. No? Somewhere it will lose contact with this vertical surface. So what is that angle where it loses the contact? Can you say how can I calculate? Normal reaction should become zero, that's all. No? When body loses contact, what will become zero? Normal reaction will become zero. So just equate that normal reaction to zero and see what is the angle where it loses contact with the convex surface. Clear now? Completed now this one? Now see. So for example, this is a convex surface. So body is traveling from here with an initial velocity of u. Let us suppose after reaching up to this position, so it is losing contact. It is losing contact. It is losing contact with me means what? It doesn't move in a circular path, just it falls down. It falls down like this. Clear now? So that angle where it loses contact, I want to calculate. So loses contact means what? Normal reaction should become zero. So just equate that equation to zero and see what is the answer you will get. Come on. How much? Cos inverse of? Oh, maybe correct. Okay, ma? So n is equals to minus mu square by L minus 2mg plus 3mg cos theta. Equate this one totally to 0. Understood now? So therefore mass, everything get cancelled. So therefore 3g cos theta is equal to u square by L plus 2g. So multiply everything by L ma. Therefore I will get 3gl cos theta is equals to u square plus 2gl. So therefore theta is equals to cos inverse of u square plus 2gl divided by 3gl. Okay. So this is that angle where body loses contact with the surface. Okay. You can call this angle as angle beta also. What is meant by angle beta? Where tension or normal reaction will become zero. So this is this angle. So previously we got u square minus 2gl, but here we are getting u square plus 2gl divided by 3gl. Fine. That's it. That completes our topic, which is called as vertical circular motion. Okay. One of the most interesting topics, very very easy topics and very important topic also. Okay. So see this question. So this is a pendulum which was given an initial velocity of root 6 GL at the bottom of this pendulum. Clear, Nama? At the bottom of this vertical motion. So we are supposed to calculate centripetal acceleration and tangential acceleration. In which condition, when string makes an angle of 60 degrees with respect to vertical. Similarly, we are supposed to find out acceleration in terms of vector form also. So this is what we are supposed to calculate. Clear? So first let us see how I can calculate centripetal acceleration. Centripetal acceleration means normal acceleration, or you can call it as a radial acceleration also, acting towards the center of the circle. So centripetal acceleration equations, one is Vt square divided by r and the other one is omega square into r. These are the two equations. Clear? Now see this circular motion. Clear, Nama? So consider this is the circle in which this bob is moving. So after covering how much angle he is saying? After covering an angle of 60 degrees. Clear, no? After covering an angle of 60 degrees, tangential acceleration will be in this direction. This is the direction of tangential acceleration. Why this is the direction of tangential acceleration? Because when body is moving, what happens to its speed? Speed reduces. No? It means acceleration is in opposite direction. Body is trying to move in this direction. So tangential velocity is in this direction, or tangential speed is like this. And acceleration is in opposite direction. Why? Because speed is reducing. Already we discussed, no? If a speed is increasing, then velocity and acceleration, they are in the same direction. But here velocity is in one direction, acceleration is in opposite direction, because velocity is reducing. Clear, no? Okay. Now what about centripetal acceleration? Centripetal acceleration will be towards the center of the circle. And centripetal acceleration either depends on omega, it also depends on tangential speed also. So Vt is nothing but final tangential speed, after covering an angle of 60 degrees. Initial velocity is already given. Initial velocity is root 6 GL. And how much angle it has covered? 60 degrees. So once I know initial velocity and angle covered, I can calculate the final velocity. Which equation? Which equation, to calculate final velocity? V is equals to square root of u square minus 2GL into 1 minus cos theta. This is the equation, no? Clear? So V is equals to square root of, what is the initial velocity? Initial velocity is root 6GL whole square, so 6GL minus 2GL into 1 minus cos 60. Cos 60 value 1 by 2. 1 minus 1 by 2 is 1 by 2, so V is equals to square root of 6GL minus 2GL multiplied by 1 by 2. That's all, no? So 2 gets cancelled, so V is equals to root 5GL. Clear now? So this is the final tangential speed after covering how much angle? After covering an angle of 60 degrees. Clear now? Now what is the length of the circular path? The length of the circular path is here. So therefore you calculate tangential speed, centripetal acceleration. So centripetal acceleration is nothing but Vt square. So root 5GL whole square divided by radius. Radius of the circular path is L. So therefore centripetal acceleration is 5GL divided by L, which is equal to 5G. So this is the centripetal acceleration. Clear, Nama? So then I want to calculate tangential acceleration. Now anybody, can you say, how can I calculate tangential acceleration? Centripetal we have calculated, no? Centripetal formula, these two are the equations. So we calculated final velocity after covering an angle of 60 degrees. This is the equation for final velocity. I have calculated, that's fine. Okay. Now how can I calculate tangential acceleration? It means somebody is pulling this bob downwards, no? That is why the speed of the bob is continuously reducing. పైకి వెళ్ళేటప్పుడు స్పీడ్ పెరుగుతుందా తగ్గుతుందా? తగ్గుతుంది. అంటే ఎవరో కిందికి లాగుతున్నారు కదా, ఎవరది? Gravitational force. So here which force is providing tangential acceleration? Gravitational force is providing. Clear, no? So how can I say, Sima? Weight mg, it is acting downwards, no? Weight mg, it is acting downwards, no? Are you able to understand? So it means acceleration due to gravity is also acting in the same direction. So this is the direction of g also, no? Acceleration due to gravity, is it a scalar quantity or a vector quantity? Acceleration due to gravity, a type of quantity. Vector quantity, acceleration, it has a direction, no? And what is the direction of g? Towards the center of the earth. So this g, you split into two components. Clear? No? So if this is 60, this is also 60. So this is a g cos 60 and this is a g sin 60. Okay. So what is g sin 60 doing? G sin 60 is the acceleration which is responsible for pulling the body in tangential direction. So therefore, G sin 60 is nothing but tangential acceleration. అదే కదా యాక్సిలరేషన్, ఇంకా వేరే ఫోర్స్ ఏమన్నా ఉందా? వేరేది అదొకటే కదా ఉండేది. క్లియర్? సో G sin 60 is the tangential acceleration which is pulling the body downwards. Clear? So therefore I say second one is tangential acceleration number. So tangential acceleration is G sin 60. That is the tangential acceleration. Okay. So calculated both of them. No? Then what he is asking? He is asking to express this total acceleration in vector form. Okay. Sima. First of all, make a note up to here. How we can calculate, how we can represent these vectors. First of all, in vector form. Clear, ma? See, ma, this is the direction of centripetal acceleration, no? So this centripetal acceleration value I know, root 5g. 5g. So this one, I should split this one into two components so that one component is along x-axis, one component is along y-axis. Then I can represent in vector form, no? Clear? So therefore, if this angle is 60, this is 60, no? This angle is 60. What is this angle? This angle is 90. Then what is the remaining angle, ma? 30 degrees. Clear, no? So it means centripetal acceleration is in which direction? So this is the direction of centripetal acceleration, no? 30 degrees. Clear? So split this one AC cos 30 and this one is AC sin 30. That's all. So therefore AC dash, how can I write? I can write AC cos 30 minus I cap plus AC sin 30 JK. I can write like this, no? So this is how I can represent centripetal acceleration in vector form. Clear? Then what about tangential acceleration? Tangential acceleration is making how much angle, ma? See, ma, this line, this radius vector and this line, they should be at an angle of 90 degrees, no? Clear, no, ma? This is the radius vector, no? And this is the tangential line, direction of tangential acceleration. So these two should be at an angle of 90 degrees. This is already 30. Then what is the remaining angle? Remaining angle should be 60 degrees. That's all. So split this tangential acceleration also into two components. Clear? So this is AT and what is this angle? 60 degrees. So this is AT cos 60 and opposite side is AT sin 60. Clear? No? So how can you write in vector form? AT cos 60, it is towards negative x-axis, no? So therefore AT cos 60 I cap minus I cap plus AT sin 60 is towards negative y-axis, no? So AT sin 60 minus j cap. Clear? So this is how I have represented these two vectors in vector form. Understood how we are doing the calculations? Just we are taking the help of these angles and we are splitting them into x-axis and y-axis components. That's it. Clear, no? So once I calculate this, then how can I calculate the total acceleration, ma? See, ma, one acceleration is like this, tangential acceleration. Another acceleration is like this, tangential acceleration. So resultant acceleration, this is the resultant acceleration, no? Yeah, already we have calculated, no? So if you want to just to find out the magnitude of resultant acceleration, then A is equals to square root of AT square plus AC square. Already we studied, no? Because these two, they are at an angle of 90 degrees. Okay? So if this is AT, this is AC. If this is AC, this is also AC. If this is AT, this is also AT. This is also a right angle triangle, no? So A is equal to AT square plus AC square. This is how I can find out magnitude. But he is not asking magnitude, no? He is asking vector form. So in vector form, how can I write? See, this acceleration, total acceleration, it is the vector sum of AT dash plus AC dash, no? I can write like this, no? So this resultant, it is the resultant of this one and this one, no? So A is the total acceleration or net acceleration. So net acceleration is the vector sum of AT plus AC. And AT AC already we have calculated, no? Just substitute that. Clear, no? So once I substitute, and now you can do the calculation, no, ma? So therefore net acceleration A dash is equals to AT. AT is how much? AT cos 60. AT value is G sin 60, no? G sin 60. So G sin 60 into cos 60 minus I cap plus AT. G sin 60 multiplied by sin 60 minus J cap plus, now you add AC dash. AC value is how much, ma? 5G, no? AC, 5G. So 5G cos 30 minus I cap plus 5G sin 30 j cap. Okay, so just simplify them, that is your required answer. Okay, now you know all the values, no? Just okay. So if you do this total calculation, this is the final answer which you should get. Minus 11 root 3 g by 4 I cap plus 7 g by 4 j cap. Okay, that's it. This is a vertical concept of again vertical motion. So what is the velocity which I am giving at the bottommost position? Velocity is root gl. Then I am supposed to find out the ratio of minimum velocity, minimum tension to maximum tension. Okay. First of all, can you say where tension will be minimum? Tension minimum ekkada untundi? Tension will be minimum at the highest position. Are you able to understand? But body can reach highest position only if it is given a velocity of root 5gl. Clear, no? Only if I give a velocity of root 5gl, then only body can reach to the topmost position and their tension will become 0. Already we have studied, no? And tension will be maximum in which condition? Tension will be maximum at the lowest position. Clear? What is the reason? Let us see. Already we have studied. Let us see once again. See now. So here, when body is present here, clear, nama? So string should bear weight of this bob also, nama? String is pulling or string is supporting weight of this bob also. So automatically here tension will be maximum. Maximum tension will occur at the lowest position. Okay. But if you see at the topmost position, string is no longer supporting weight of the body because weight is falling downwards. String doesn't support the weight of the body, no need to support weight of the body. Or you can do one thing. So here if velocity is VL, velocity at the lowest point, then I can write T minus mg. T minus mg provides centripetal force and it is VL square divided by L. I can write like this number. T minus mg. Why T minus mg? Because two forces, they are acting in opposite direction. Tension is towards the center of the circle. mg is in opposite direction to the direction of the center of the circle. So T minus mg provides centripetal force. So therefore what is the tension at the lowest point? It is mg plus VL square divided by L. Okay. So this is the equation for tension at the lowest position. Now if you see the highest position, clear? So this is the center, tension is acting in this direction and mg is also acting in the same direction. Tension is always towards the center of the circle, weight is always towards the center of earth. So here weight is also acting towards the center of the circle. And here let velocity be Vh, velocity at the highest point. Clear, nama? So therefore who is providing centripetal force here? Who is providing centripetal force? T and mg both are providing, no? Both of them, they are acting towards the center only, nama? So T is also providing, mg is also providing. So therefore what I will write, T plus mg is equals to mvh square divided by L. So what is the tension at the highest position? Th is equals to mvh square divided by L minus mg. So this is the tension at the highest position. Clear? No? Now you see this equation and this equation, where tension is maximum. By looking at the equations I can say, nama, where tension is maximum? At highest position or at lowest position? Definitely at lowest position tension is maximum. Why? Because here we are writing mvl square by L plus mg. Tension has increased. But here we are writing mvh square by L minus mg. We are subtracting mg from here. So definitely TL must be always greater than TH. Tension at lowest point is always greater than tension at the highest point. Clear? So TL is greater than TH always. And already we have derived one relation, number TL minus TH is equals to 6 mg. This also we have derived. No? TL minus TH is how many times the weight of the body? 6 times the weight of the body. Clear? Okay. Now he is asking these values now. So he is asking to find out ratio of tension at the minimum position and ratio of tension at the maximum position. Okay. First of all, you should calculate what is that position where maximum tension occurs. Because only if I give a velocity of root 5gl only, then only it can complete a circular path. But we are giving how much velocity? Only root gl. So definitely body cannot move to maximum height. Okay. It will move only particular position. That position first you find out, then you calculate the tension. So as body starts moving upwards, what happens to tension? Increases or decreases? Decreases, no? Because here it is maximum, here it is minimum. So find out that position where minimum tension occurs first of all, if I give this much velocity. Tension at maximum already we know. This is at the bottom of the circle. Okay? Try cheyandi. Question is that this is a circular path, clear? So here there is a body of mass m which is released. Initial velocity 0 ante akkadi nunchi release chesam kada. We are releasing the body and there is no friction. So question is, what is this minimum height? Minimum height is how much such that body can complete a circular path. Body should just be able to complete a circular path. Clear now? Then what is the minimum velocity? Minimum height from which I have to release this body. Can you say how can I solve? Ela cheyochu cheppandi. See, already we studied that this case is a convex circle case, no? Concave circle case, no? Already we studied that this case and motion of a pendulum both are analogous to each other, no? Already we studied, no? So this case and motion of a pendulum with the help of a string, these two are analogous. Similarly, motion of a rod motion also we studied, no? Similarly, motion of a bob in a frictionless tube, these two are analogous. So therefore, for this body to complete a circular path, after some time it will reach up to here, no? It will reach the bottom of the circle. So at the bottom of the circle, how much velocity it should have? It should have a minimum velocity of root 5gl. Then only it can complete a circular path. Already we studied. At the bottom of the circle, minimum velocity required is root 5gl. Then only body can complete a circular path. And here L is nothing but R, no? So instead of L, I will write root 5gr. So this is the minimum velocity body should have at the bottommost point of the circle. So initial velocity is how much? U. Final velocity is how much? Root 5gr. Then can't I use law of conservation of mechanical energy here? So body is coming down. How many forces are acting on this mass? Only gravitational force is acting, which is responsible for doing some work. Normal reaction is also there, no? Normal reaction is also there, but normal reaction cannot do any work. Normal reaction cannot do any work, no? Because normal reaction is in this direction. Displacement is in this direction. So what is the angle between them? 90 degrees. So normal reaction cannot do any work. So only force which is doing work on this body is gravitational force. And gravitational force is what kind of force? Conservative force. So if only conservative forces are acting, what can I do? Law of conservation of mechanical energy. So K1 plus U1 is equals to K2 plus U2. That's all, no? Initial kinetic energy, 0. Initially it was in rest position, no? Initial potential energy, that depends on the reference. So which reference shall I take? I will take bottommost position to be 0 potential energy reference condition, this position. Clear, no? So initial potential energy, mgh. Height I don't know, no? So mgh. Final kinetic energy, root 5gl should be the velocity, no? So kinetic energy is half into m into v square. So root 5gr whole square. That's all, no? Final potential energy, when body reaches this position, what is the final potential energy? Final potential energy is 0. Height is 0, right? We are not discussing about height. We are discussing potential energy at this position. It is at 0 reference condition, no? So potential energy will be 0. Now do the calculation. So mass and mass get cancelled. So GH is equals to 5gr divided by 2. So G and G get cancelled. So H is equals to 5r divided by 2, 2.5r. So this is the minimum height from which I should release the body so that body can complete a circular path. So if I release more than this height, what will happen? No problem. Definitely it will complete a circular. But if I release less than this height, body cannot complete a circular path. That's it. Okay.